Okay, round 2, trying the same question again. So my pen stopped working. So 3 cosine 2 theta is equal to tan 161. Why would you not just put tan 161 into your calculator? Once you've got tan 161, so that's just a number, you're going to divide that side by 3, divide that side by 3, and now we can find out what the angle is. So I'm going to go shift cosine, and I'm going to type in at the top my negative answer, and at the bottom 3, and I actually think it was, let me just change it back from being negative to positive, and end up with hopefully the right angle. So just type it in. So our angle is 96.5 degrees. So 2 theta is 96.5 degrees, and you're going to add K360, and remember to say K is an element of integers, and you're going to do its cosine, so you're going to do the same with the other angle. 2 theta is equal to minus 96.5 degrees plus K360. I doubt you need help from here onwards. Obviously, I'm just going to divide everything by 2 and then carry on. So I guess, no, I really don't feel like doing this. I really don't think that this is the problem, right? But we're going to do that, and we're going to do that. And our angles are 48.3 degrees plus K180 and negative 48.3 degrees plus K180. And they just are asking for the general solution for this one, which, by the way, is very unusual. For AS, they're not going to ask you for a general solution. They'll ask you for actual solutions within a domain, usually starting at 0 and going to 360, but sometimes maybe from negative 180 to 360 or something. Anyway, there's our general solution. So that is not a hard question. Tan 161 is just a number. The other one I was asked to do is exactly the same. So it's the same thing again. Tan 340 is just a number. So again, you're going to just go tan 340 and end up with negative 0.364, rounded to 3 significant figures. And that's 2 sine 3x. We don't want 2 sine 3x. We just want sine 3x. So we're going to do that. And again, I can go shift sine. Let me do that. Shift sine fraction. And my fraction is negative 0.364 over 2. And I'm closing my bracket. And my angle appears to be negative 10.4 or negative 10.5 degrees. So 3x is equal to negative 10.5 degrees. That's our angle. And then it's sine. So we're going to do exactly the same as we would usually do. And we're just going to say plus K360. And then it's sine. So the other general angle is 3x is 180 degrees minus negative 10.5 plus K360. So we've got 3x is equal to minus 10.5 plus K360. And I've got 3x is equal to 190.5 plus K360. And then again, it's the same thing as usual. Divide everything by 3. And those, you're going to pick up all your different angles, right? So we're going to have every 120 degrees. And I don't think you will need me to go to more detail. So, I don't know how well my recordings are going. I'm having lots of glitchy stuff happening with the hardware here. Anyway, there's the final answer for that one. Should not be a problem, and the steps are inside the notes. Here's question 7. You've got to think to yourself, well, there's a limited number of things I can do here, right? Your whole point for any equation is to get the equation to look like this. If you're solving an equation, what you want is x plus 3, x minus 2 equals 0, then x is equal to minus 3, and x is equal to 2. Isn't that done? Isn't that what you have? So in other words, they factorize it for you already. All you need to do is now work out the answers. So 2 cosine x plus 1 equals 0 is your one thing. and 2 sine x minus cosine x equals 0, because it's fully factorized, right? So then this is 2 cosine x is equal to negative 1, and obviously we're going to divide by 2, and we're going to use cosine of negative a half, and that's going to give you two angles which are 120 degrees. So x is going to be 120 degrees, and so you're going to have your angle, which is 120 degrees, plus K360, and you're going to have your negative angle, which is negative 120 degrees, plus K360. So that piece is very easy to solve. For the other one, you've got 2 sine x minus cosine x, which is the same thing as saying 2 sine x is equal to cosine x. Now, you could go and change cosine x to sine x, but we wouldn't do that here, because if I did, if I've got 2 of something, it equals 1 of something. I mean, let's pretend I do that. So if I do it the wrong way and I say 2 sine x is equal to the same as sine of 90 degrees minus x, which is this one here, right? If I go and change it from cosine to sine, how can I make these equal? This one's got a 2 in front of it. This one's got nothing, right? So they're not the same thing. In order for this to work, I have to have sine x is equal to sine, or I don't know, x plus 20, right? Then obviously that piece must be equal to that piece, right? So or if I had 3 sine x and 3 sine x, then still that piece is equal to that piece, because they're the same thing. But for this one, 2 sine x can't be equal to just sine x. So we've got 2 different methods when we have a mixture between the ratios. So the one is to reduce it and go 90 degrees minus, and the other one is to make tan. If the angle is the same, so if you look at this one over here, this is x, and this is x. If the angle is the same, you want to do tan. So what I'm going to do is I'm going to divide both sides by cosine x. That side and that side. Remember, this is an equation, so I can do that. So now I've got, oh my God, the bloody pen is stopping working again. This is being really, really difficult. But anyway, at this stage, I'm going to have 2, and it's not working again. Okay, there we go. Okay, at this stage, I'm going to have 2 tan x on that side, because that's what sine x over cosine x is. And on this side, I've got 1. So now I've got tan x is equal to a half, which is probably what you would have seen inside the memo, and maybe wondered where on earth that came from. Again, you're going to go shift tan x, get your angle, which is 26.6. So then it's going to be x is equal to 26.6 degrees plus K180, because it's tan, and that's it, and you're done. So if they've already factorized it fully, then they've done the work for you. You don't need to do more. And remember, if you have sine and cosine of the same angle, you can almost certainly make it into tan. So here's another type. So we've got sine and cosine of the same angle, but the one's squared and the other one isn't, so that's not tan. So you can either reduce the angle, and you could say 90 minus to get something in terms of sine, but life is going to get very, very difficult. If you can see it's sine squared x, why not use the identity? Why not say sine squared x plus cosine squared x is equal to 1? So in other words, 1 minus cosine squared x is the same thing as sine squared x. And now if you start to look at what you have, you are heading towards a trinomial. So this is 2 minus 2 cosine squared x equals to 3 cosine x. I'm going to move everything across onto the other side, because you don't want your thing with a square to be negative. And then I've got plus 3 cosine x, and then I've got minus 2. So you are just going to be factorizing that. That's a dead straightforward trinomial. You need factors of 2 that add, and factors of negative 2 that add up to give you positive 3. Remember, you could think of this as being something like 2k squared plus 3k minus 2. So that should not be a problem to factorize. So that's 2 cosine x minus 1. And then obviously cosine x plus 2. At that stage, we can now finish this thing off. So I've got 2 cosine x is equal to 1, and cosine x is equal to 2. Cosine x, negative 2. Cosine x can't be equal to negative 2. Remember, cosine x is the relationship between the adjacent and the hypotenuse. And you're saying that the adjacent side is twice the size of the hypotenuse. It's absolutely impossible, and that is invalid, right? It has to be, cosine x has got to be a fraction, and it's got to be it's got to be less than 1, or 1, can't be more than 1. This one is fine, so we can divide that side by 2 and that side by 2. Cosine x is equal to a half, which is the angle 60 degrees, and again, it's going to be plus or minus 60 degrees. Plus K360, because it's cosine. So a question like this can have 4 different solutions. You could have 2 solutions from the one side, from this one over here, and another 2 solutions from there. Sometimes all of the solutions are valid, sometimes only half of them are. Then question 11, same sort of question as question 10. You can see that because you've got cosine squared x again, and you've got sine x. How's that going to work? You need to have either, you need to have the same ratio. So again, you could try reducing the angle and put 90 degrees in and make your life really, really awful. Or we'll just replace the cosine squared x. So this is 1 minus sine squared x. Again, using the identity, minus 5 sine x minus 1 equals 0. We may as well start getting it ready for factorizing. So that's 3 minus 3 sine squared x minus 5 sine x minus 1 equals 0. So I've got minus 3 sine squared x minus 5 sine x. Then 3 minus 1 is generally speaking 2. And all my signs are wrong. It's going to make my life very, very difficult to factorize. So I am going to change all of them. So I'm just going to make that one 3 sine squared x plus 5 sine x minus 2 equals 0. So we're talking about factors of 3 and factors of negative 2. So just straightforward factorizing again. 3 sine x on that side, and then we'll have sine x over here. And we need factors of negative 2 that will work, which is going to be minus 1 and plus 2. And that's just ordinary factorizing as usual. So I've now got 3 sine x is equal to 1. And sine x is equal to negative 2. Same problem as for the other one. It's too big. Remember that sine x, the amplitude is 1. That's the biggest it can get. This one we can do. So we've got a third. And again, pop it in your calculator. X is equal to 19.3 degrees plus K360. And this is sine. So the other one is going to be x is equal to 180 degrees minus 19.3 degrees plus K360. Which turns out to be 160.7 degrees plus K360. So at that point, it's just the same as usual, and you finish the thing off. So we've got quite a few different types of questions here, and you need to recognize which one is which. Question 12, again, sort of looks like factorization. So you've got 4 cosine squared theta. You could change that to sine squared theta, but how's that going to help? We've got a middle term that has both sine and cosine in it. So what we really need is we need a trinomial in this form. We've got a term that looks like this. We've got a term in the middle that looks like that, right? I mean, more or less like this. What we need at the end is a term that looks like that, right? Then we will have a trinomial that you can actually factorize. So what we're going to do is change the 2. So you know what 1 is equal to. Well, 2 is equal to the same thing, but twice. So 4 cosine squared x plus 3 sine x cosine x is equal to 2. And 2 is 2 times 1. And 1 is sine squared x plus cosine squared x, as you know from the identity, right? So now we've got 4 cosine squared x plus 3 sine x cosine x equals 2 sine squared x plus 2 cosine squared x. And I'm obviously going to bring everything across and make this look proper. So I'm going to subtract 2 cosine squared x from both sides. So I've got 2 cosine squared x over here. Still got the middle term, which is 3 sine x cosine x. And then I'm going to bring the sine term across by subtracting minus 2 sine x from both. So there we go, factors of 2 and factors of negative 2 that add up to 3. Factorizing again, so this is 2 cosine x minus sine x and cosine x plus 2 sine x. So that's straightforward factorizing. I'm busy copying from the memo, but it should be super easy for you to do, hopefully. Once you're at this point, we've got 2 cosine x equals sine x for that one. That is the same angle, we're going to use tan, right? And then we've got cosine x equals 2 sine x, for negative 2 sine x for that one. Same angle, we're going to use tan. So I'm going to divide this side by cosine x, that side by cosine x to make tan. And 2 is equal to tan x. And then the same thing over here. Divide by cosine x, divide by cosine x, and 1 is equal to minus 2 tan x. Don't want minus 2 tan x, going to divide both sides by minus 2. There's tan x. Tan x can be 2, so there's no problem with that. You're going to have the answer, which is 63.4 degrees. So x is equal to 63.4 degrees plus k180. And because that tan only has one general solution, that's it. And tan can be negative a half. There's no problem with that. So we've got negative 26.6 degrees plus k180. So I am concerned that these are the only questions. I find that hard to believe. I wish you luck because I think you're going to need it. You need to have done these questions. You need to have caught up. But anyway, let's hope that you're fine.